Hello. So welcome to another video on the Chapter 8 practice test. So in this test, we're going to look at the two levels, the reasoning and modeling, as well as the understanding and solving. And also the formula are given in the first page, so make sure you use the formula properly. Let's look at the question number 1. Solve the exponential equations. So when you want to solve exponential equations, well, the first thing we need to do is undo the exponents. So how do we undo the exponents? We undo the exponents by taking a logarithm on both sides. So the first thing that I would do is to log both sides. And because there's a base of 3 on the left-hand side, I'm going to do log base 3 on both sides. So on my left-hand side, log base 3 and the base 3 will cancel out. So I'll have x plus 1 equals, and also the log base 3 of 81, I can compute that using a calculator, using a scientific calculator. Which is equal to 4. So minus 1 on both sides, it's equal to 3. After you solve the exponential equations or any logarithmic equations, and it is a good idea to check your answer afterwards. So let's check your answer. 3 to the power of 3 plus 1 is equal to 81. 3 to the power 4 is equal to 81. So 81 is equal to 81. So yes, it is the right answer. Let's continue on the same way. Second question, this time the base is e. So let's do ln. Let's do a ln on both sides, the natural logarithm on both sides. So the ln and the base e will cancel out. And it's okay to leave the ln 7 as it is, because if you plug in the ln 7 on the calculator, you'll probably get just all decimals, which is not a good idea. So x equals ln of 7 plus 3 divided by 2 is my final answer. Once again, let's check the answer by plugging the values. 2 times ln of 7 plus 3 over 2 minus 3 is equal to 7. So I'm going to use my calculator to do that. E to the power of 2 times bracket ln 7 plus 3 divided by 2 close bracket minus 3. It's indeed equal to 7. So we know that the answer is correct. Part C. 4 to the power of 2x equals 3 to the power of x plus 3. So for this case, the bases are different. So it means that we have to do a log on both sides, but the base is not important in this case. So this time I'm just going to do a log on both sides without the base. Without the base, it means that the base is 10. So let's do log on both sides. Now, I'm going to use the power law of logarithms, which means that the power comes down as the coefficient of the logarithm. Like this. Now, it doesn't look like one, but we're dealing with a linear equation because our variables have no powers and they're just living in the overworld. So now let's collect like terms. It's going to be 2 log of 4 times x equals, expand the right hand side, log of 3 times x plus 3 log of 3. So let's put all the x related stuff on the left hand side. Now let's factor out x. Finally, isolate x by dividing both sides. So if I wanted to, I can go a few steps further, but I don't think it'll be too necessary in this case. It wouldn't give out any useful information, so I'm going to pause here. Of course, you can plug into the calculator to check your answers. So approximately, this is a 3 log 3 divided by 2 log 4, close bracket, minus log 3. And that's equal to, let's save it as a. So it is approximately equal to 1.97. So let's do 4 to the power of 2a is approximately 234. And then let's also do 3 to the power of a plus 3, which is also equal to 234.83. So I know that we have found the right answer. Move on to the second question. Evaluate or simplify the expression using a single logarithm. So the first thing is pretty simple. We have a power inside the logarithm, so I think we can bring it down using the power law. So that's going to be 3 log base 2 of 4. And I think log base 2 of 4 is quite easy to compute. It's going to be 2, because 2 squared is 4. So the final answer is 6. Log base 4 of 3x plus log base 4 of 2. So this one, it seems like we're using the law of the product law, which means that if you have addition, the sum of two logarithms with the same base, we can multiply the insides together. So it's going to be log base 4 of 3x times 2, which is log base 4 of 6x. The final part, ln 4 minus ln 2 plus ln of half. So first of all, let's do the first ln 4 minus ln 2, which is called a quotient law. If you have the two logs, the difference of two logs with the same base, then we find the quotient of the inner sides. So the first one is that ln of 4 over 2 plus ln of 1 over 2, which is ln of 2 plus ln of 1 over 2. Now, we have another law to use, the product law, which means if we have the same sum of two logs with the same base, we multiply the inner sides. It's going to be ln of 2 times 1 over 2, which is ln of 1. Now, if you know about the logarithmic function, you know that any logarithms, whatever base they have, the x-intercept is going to be 1 comma 0, which means that when x value is 1, the y value is 0. So this is equal to 0. Moving on, question number 3. Solve the logarithmic equation. So now we need to undo the logarithm to solve this equation. The first question we have the log base 5 of x equals 2. So in order to undo the logarithm base 5, we need to do the base to the power of dot dot dot. Remember that, base to the power of dot dot dot, in order to undo the logarithm. So I'm going to do base to the power 5 to the power of on both sides. So 5 to the power of log base 5 are going to cancel each other out. X equals 5 squared. X equals 25 would be the final answer. Let's do the same question, similar question. 2 log base 2 of x minus 2 equals 1. So first of all, I'm going to isolate log of x minus 2. Now, once again, let's do base to the power of on both sides. The normal log without the base has a default base of 10. So I think I'm going to do 10 to the power of on both sides. And my left-hand side will be cancelled like this, x minus 2. The right-hand side will now have 10 to the power of 1 over 2. So my final answer is, and 10 to the power of 1 over 2 can be rewritten as square root of 10. So it's going to be 2 plus square root of 10. That's my final answer. Oh yeah, sorry, I forgot to check the answers here. So now let's go back and check. Log base 5 of 25 equals 2. And I can go to the calculator to check that. Log 25 divided by log of 5. And indeed, it's 2 equals 2. So yes, it is the right answer. Let's try the other question as well. So I'm going to check that 2 log of 2 plus square root of 10 minus 2 equals 1. I'm going to just use a calculator. 2 log of 2 plus square root of 10 minus 2, close bracket, and it is indeed equal to 1. So yes, that is the right answer. Let's do the final part. Ln of x minus 1 plus ln of x plus 1 equals ln of 8. So the question is a bit more complicated because we can't just undo the log right away. I think in order to undo the log right away on both sides, they need to be isolated on either sides. So the first thing that I'll do is I'm going to combine the two logs on the left hand side together into one single logarithm. And because we're doing a sum of two logs with the same base, we're going to use a product law, which looks like ln of x minus 1 times x plus 1 equals ln of 8. So that's going to be ln of x squared minus 1 equals ln of 8. Hopefully you remember the difference of squares formula. So now we can undo the ln on both sides. Well, we can do e to the power of the base to the power of on both sides, which will automatically cancel both ln on both sides. So x squared minus 1 equals 8. X squared minus 9 equals 0. X is equal to, sorry, x squared is equal to 9. I probably should have done that right away. Actually, let's go the other way. X squared minus 9 equals 0. So now let's solve the equation by factoring. It's going to be x minus 3 times x plus 3 equals 0. So x equals 3 and also negative 3. So are these both the correct answers? Well, we'll need to check by putting in the calculator. So let's first check that x equals 3 is the correct answer. Ln of 3 minus 1 plus ln of 3 plus 1 is equal to ln of 8. Once, let's check using the calculator. Ln of 3 minus 1 plus ln of 3 plus 1 is approximately 2.79, so 2.079, so that's 2.8. 2.08. And its ln of 8 on the other side is going to be also 2.08 approximately. So yes, we have checked that x equals 3 is the correct answer. What about negative 3? Now let's try to put the ln of negative 3 minus 1 plus ln of negative 3 plus 1. And the calculator shouts at me and says undefined on the left hand side. So this happens because the log has a domain that x value needs to be a positive, but negative 3 minus 1 is negative 4, which is negative. Negative 3 plus 1 is negative 2, which is also negative. So because we have negative values in the log, it is undefined. So therefore, x equals negative 3 is not our answers. So my final answer is going to be x equals 3 and only 3. Right. Right. Moving on, let's try the question number 4. Consider the function f of x equals log base 3 of x. First, let's sketch the graph of f of x. Remember that I told you multiple times that when you draw the graph of when you draw the logarithmic function, the key information that we need to always include is the vertical asymptote. That is x equals 0 is the vertical asymptote. And also we have a x-intercept at 1 comma 0. And the shape of the graph looks like this. So that's the graph of f of x, log base 3 of x. Now let's sketch the graph of the transform function g of x equals negative f of 2 times x minus 1 on the same set of axes. First of all, let's analyze the information and try to make a graphic organizer. Vertical, horizontal, SRT. There is no stretch in the vertical side, so that's 1. Horizontal stretch, it seems like it's going to be 1 over 2 because the coefficient is positive 2. So that means that horizontal stretch by a factor of 1 over 2. And then we have a vertical reflection. Yes, we do have a vertical reflection, and we do not have the horizontal reflection. We do not have a vertical translation. Sorry, so that's 0. And we do have a horizontal translation of 1 unit to the right. So let's do some transformations one by one. First thing that's going to happen is that we have a horizontal stretch by 1 over 2, which means that when you do the horizontal stretch, the invariance point is the oh, the x equals 0. So I think the vertical asymptote stays the same. However, my x-intercept is going to be transformed to 1 over 2 comma 0. So that's the graph of the transform function after we do the horizontal stretch. Afterwards, we need to do a vertical reflection. So it means that the invariant point is that the x equals 0, the vertical asymptote, and 1 over 2 as the x-intercepts are invariant points, but the other graph is reflected upside down. Finally, we have a horizontal translation, 1 to the right. So it means that all parts of my graph will be moving 1 to the right. So it means that my x-intercept will be moving. Sorry, my horizontal asymptote will be moving 1 step to the right. Sorry, vertical asymptote will be moving 1 step to the right. X equals 1. And my x-intercept in the previous step was 1 over 2. So my new x-intercept would be at 1 and 1 over 2, so 1.5 comma 0. And the graph will look like this. So I think this blue graph is the final version of the g of x. And the red one was f of x. State the domain of g of x and explain why the logarithmic function has a domain restriction. So the domain of g of x is that this graph only exists when the x value is greater than 1. So I think the domain of g of x would be x is greater than 1. So why does my logarithmic function has a domain restriction? Well, after all, it's a logarithmic function, right? So if I rewrite the g of x with the logarithmic stuff, it's going to look like g of x is equal to negative log base 3 of 2 times x minus 1. So there is a necessity that this 2 times x minus 1 is greater than 0. Remember that for all logarithmic function, we have a domain that x is greater than 0. Whatever inside the logarithm has to be positive. So in order to have 2 times x minus 1 to be positive, well, x minus 1 has to be positive. So therefore, x has to be greater than 1. Last question, number 5. The compound interest formula is a equals p times 1 plus I, close bracket, to the power of n. Blah, 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 blah. There's one thing to watch out for is that n is a number of compounding periods. We need to be careful when we calculate the numbers. And finally, the interest rates given in the question are annual percentage rates, not the rate per compounding period. Okay, the question percentage given to you is not the same as the I value, the interest rate per compounding period. So watch out for that. Okay, so let's try the question here. Doe bought a new $2,599 television using a credit card. The rate of interest charged on the overdue balance is 22.99% compounded daily. How many days is Doe's payment overdue if the amount shown on this credit card statement is $2,682.13? So, first thing, let's analyze the question and write down the values that we know of. I think we know the A as a future amount, to be 2,682.13. I also know that P, the principal value, the present amount or principal, is equal to 2,599. We also do know that I, well, in this case, I is quite complicated. I is the interest rate per compounding period. So first thing, the 22.99% is actually compounded daily. So I think we're going to do this number, 22.99%, divided by the daily. So there's in a year, let's assume that we have 365 days in a year. So I will be 22.99% divided by 365. Or we can rewrite it as 0.2299 divided by 365 is my I value. Finally, n is actually in this case the unknown value because we need to find the number of days that was. So let's put it as x. So now let's put it into an equation. 2682.13 is equal to 2599 times 1 plus 0.2299 divided by 365 to the power of x. So, right off the bat, I have my variable in the power position, so it feels like that we need to use some kind of logarithm to solve this question. First thing, let's isolate x one by one. I think we need to divide both sides by 2599. Now, let's do log on both sides to um, undo the base of 1 plus 0.2299 divided by 365. So my x is going to be log, watch out here, of log base of 1 plus 0.2299 divided by 365 of 2682.13 divided by 2599. So let's put that into calculator and see what we get. Log of 2682.13 divided by 2599, close bracket, is divided by another log of 1 plus 0.2299 divided by 365. And the answer that I got on my calculator is approximately 50.00. So I think that's x is 50. So remember that n value was a number of compounding periods. So in this case, I have 50 compounding periods, but I have a daily compounding period. So I think 50 days is my final answer. So it means that the overdue payment was 50 days. All right, last question. Hoon invests $7,000 in a guaranteed investment certificate, or GIC, that earns 5.7% compounded quarterly, which is 4 times per year. Approximately how many months will it take for the GIC to be worth $10,000? So once again, let's analyze the information. A is equal to 10,000, future value. P is equal to 7,000. And I is equal to, well, it says 5.7%, but we're compounding quarterly, 4 times a year, so I think we're going to divide it by 4, or 0.057 divided by 4 is my I value. And once again, n is my unknown value x. Watch out for this one. N is the number of compounding periods, so my x value that I get at the answer will not be the direct answer. So we'll go back to that later. Anyways, let's copy this number down into the formula. 10,000 equals 7,000 times 1 plus 0.057, sorry, divided by 4 to the power of x. So let's solve for x one by one. Divide both sides by 7,000, so it's going to be 10 over 7 equals 1 plus 0.0057, not 0057, 0.057 divided by 4 to the power of x. So similar to the previous question, let's do log on both sides. So x is equal to log base of 1 plus 0.057 divided by 4 of 10 over 7. So put that into calculator, and approximately we get log of 10 divided by 7 over log of 1 plus 0.057 divided by 4. And the answer that we got is approximately 25.2. So what does this number mean? We have 25.2 compounding periods before we reach the $10,000 goal. Now, we know that one compounding period, so this is 25.2 compounding periods. And we know that one compounding period is quarterly compounded, so I think that's going to be 3 months, isn't it? So it means 25.2 compounding periods will be equal to 25.2 times 3 months. So that's going to be approximately 75.6 months is the final answer. Approximately 75.6 months before the GIC will be worthing $10,000. This question is not very realistic because GIC usually has a set number of years to mature, and then we have to leave the GIC afterwards. But that's okay. All right. Hopefully you follow along the practice test solution. Good luck with your study.